Hi there science students. In this video we're going to look at momentum. Just want to note that momentum appears in Criterion 5 in the form that we're looking at it today. It'll also come up again in Criterion 6. It'll be a bit more complex then because we'll have to examine how momentum is conserved in collisions. So first off, the formula for momentum. So we have this. Momentum, we have the letter P, and it's equal to mass times velocity. So P equals mv. It's a vector quantity. And the units are kilograms meters per second. So how many kilograms are moving at what speed? So we'll do a couple of quick examples here, and you might even feel confident enough to pause the video at this stage and try these on your own, but I'll have a go at them. Okay, so first off, we need to convert this unit here, which is in grams, into kilograms. So we divide that by 1000, and that gives us 0.055 kilograms. The unit here for speed is okay. That's in standard units already. So the momentum, P, is equal to the mass, 0.055, multiplied by the velocity, 2.5. Which gives us 0.1375. So we have the units, kilograms meters per second, and we have the direction as well because it's a vector quantity. So this is to the north. Now you might want to pause the video and try this next one on your own now. Then I'll have a go at it. Okay, with this one, we need to be careful here because the standard unit for speed is meters per second, so this needs to be divided by 3.6 to make it into meters per second. 60 divided by 3.6 gives 16.7 to three significant figures, meters per second. So now we can go ahead and calculate the momentum. Mass times the velocity. Which is 25,050 kilograms meters per second, and once again this direction is north. Now the other one that we need to consider is change in momentum. That's also known as impulse. If you see that word impulse, that means the change in momentum. We're going to use the delta symbol that we've seen earlier. And change in momentum is equal to mass times change in velocity. Or we could write this as change in momentum equals mass times v take u, because to calculate the change in velocity, we do the final velocity subtract the initial velocity. So you might want to pause the video and have a go at this one on your own now. Then I'll have a go at these two examples. So in this first one, all the units are standard, that's fine. So the mass is equal to 50 kilograms. The initial velocity, well, they start from rest, so that means it's equal to 0. And the final velocity is 25 meters per second. So the change in momentum is equal to the mass by v take u. So 50 by 25 gives us 1,250. There's no real direction given here. We'll just assume the person's running forwards. Now this one, a little bit of work to do. Did you remember to convert these into meters per second? Divide them both by 3.6. We already found out that 60 kilometers per hour was 16.7, didn't we? So we'll keep that one. So that means U is equal to 16.7 meters per second. And if we divide 100 by 3.6, that gives us 27.8. So the final velocity, 27.8 meters per second. The mass, 1,500 kilograms. That's standard units. So the change in momentum this time is equal to that mass by 27.8 takes 16.7. Uh, 16,650 kilograms meters per second. Once again, no particular direction given. I'll just say forwards this time. Right, so a couple of trickier ones here. We'll leave these ones for you guys to try and check the solutions in the notes. Just wanted to add something to this. There's not enough information in this second one to actually do it. So we're going to say that this occurs, it changes its momentum by this much in 5 seconds. Now both of these involve using the same formulae that we had before, but there's going to be some transposition involved. So I'll leave those with you. These are trickier ones. So go ahead now and practice some questions on momentum.